In example 5, we're going to use some reference triangles to find sine, cosine, and tangent of these following values. Okay, we are going to do this based off of reference angles that are in the special angle category, the 0, 30, 45, 60, 90, etc. So I'm going to keep this table handy. You're going to need it. So first of all, 225. What quadrant is it? What is the reference angle? So I've got 90, I've got 180, and I've got 270. So we're somewhere in this quadrant right now. So I'm going to draw that triangle in first. Somewhere in this quadrant with an angle of 200, so quadrant 3 of 225 degrees. Now what I want to know is how much larger is that angle than 180? I know this axis was 180. So if I take 225 and I subtract off 180, I find that the reference angle is 45. So this is 45 degrees, and that's my reference angle. That means that 45 is going to be the angle that has the same, plus or minus, of course, trigonometric ratios. Okay, so I am going to make a quick chart of my sine 45, my cosine 45. I just need sine, cosine, tangent, and my tangent 45. I know these are root 2 over 2, and you can look them up on the previous page, root 2 over 2 and 1. Now, what I want is, what does this tell me about the actual angle I want? I actually want to know what sine of 225 degrees is. I want to know what cosine of 225 degrees is, and I want to know what tangent of 225 degrees is. That's what I want. They're going to be the same, plus or minus. So remember our quadrants. In the quadrants right here, all students take calculus. Tangent is the one that's positive. The other two are going to be negative. So it means I'm going to have negative square root of 2 over 2, negative square root of 2 over 2, and positive 1. And those are the three trigonometric ratios for the angle 225. I need to know the sine based on the quadrants. So the x value and the y value of this ordered pair are both negative, so it's negative comma negative, and therefore anything that involves the radius will be negative, because one negative, one positive, and then tangent, which involves both of those two values, will be positive. Let's try it again. The next one, the angle in question is negative 120 degrees. So what quadrant would that be in? So first, a quick little sketch. Negative 90, negative 180. So we are in quadrant 3 again. Okay, that's negative 120 degrees. Find its reference angle. Its reference angle is going to be the triangle that goes up to the x-axis. So that's the reference angle. So I want to measure that as something that is past 180. So I'm going to take 180 minus 120 and find that little angle inside this triangle. So this is going to be a I'm going to just arrow it in. It's going to be a 60-degree angle inside. Again, I might not have drawn it to scale. It's a 60-degree angle. It's not a 30-degree angle. It's 60 degrees. It's in this quadrant with a 60-degree angle in this corner. So I'm going to be using what I know about sine, cosine, and tangent of 60 degrees. Okay? So first of all, I'm not going to write down both of them. I'll look them up. So what I want to do is sine of negative 120 degrees, cosine of negative 120 degrees, and tangent of negative 120 degrees. Okay, so let's do the positives and negatives before we go on to the actual values, because I know that this is again in quadrant 3. All students take calculus. Tangent's the only positive one. I have a negative, and a positive. And then back to the values. These are the values from 60. The sine of 60 is the square root of 3 over 2. The cosine of 60 is 1/2, and the tangent is the square root of 3. So I have my 3 primary trigonometric ratios for negative 120 degrees. For the next part here, it's important to note that using arcsine, arccosine, and arctangent on the calculator, they return an angle, but it only ever yields the reference angle. So, for example, if I was to compute the arcsine of negative the square root of 3 over 2, I would get the reference angle negative 60 degrees instead of the negative 120 degrees. I would not get the full angle. Okay, so let's explore that in the next section here. Given the function's ratio and the quadrant restriction, find the angle. All right, so I'm going to draw a quick little picture because I just want to know what angle it's in, so quadrant 3. So there is some angle in quadrant 3. I want the actual angle, and so we want the smallest positive angle. When I'm looking for find the angle, usually the smallest positive angle is what I'm looking for. Of course, there are coterminal representations. I can find a coterminal as well. What I don't want is the reference angle. So I don't want an angle that is only, like for example, this angle is not 45 degrees. It's referenced by 45 degrees because it's 45 degrees beyond 180. So I want the 225 for that one. Okay, so what we're going to do first is arctan that value. So I'm going to use the calculator just because I have it handy here. So I'm going to take the arctan of 0.2460, and that gives us an angle value of 13.82. So I'm going to write that down. So first of all, theta is equal to the arctan of 0.2460, and that gives us a reference of 13.82 degrees. Now, 13.82 degrees is in quadrant 1. This angle is in quadrant 3. That means that this measure past 180 has to be 13.82 degrees. So the full angle, since I know it's in quadrant 3, has to be beyond 180 by that measure. I'm going to add 180 to it to get the actual angle. The actual angle is 193.82. So the angle theta is 193.82 degrees. Now, this angle that I found up here is not theta. I can call it something else like phi. I have a phi, a reference angle of 13.82, but theta, the one that's in quadrant 3, is 193.82 degrees. Notice that if I take the tangent of that angle, I do get the 0.2460. Of course, it's off a tiny bit because I had to round the angle, but this does round up to 0.24.599, which is 0.60. So it is does give me the same ratio as my target right there. Okay, let's try another one. All right, so in this next one, we need to be in quadrant 4. In this next one, I want to find an angle such that its sine is negative 0.43 degrees and it's in quadrant 4. So it's down here somewhere. The angle that I'm looking for is going to be all the way around to get there, the positive angle. But the first thing I'm going to find is a reference angle, so I'm going to call this one phi, that's going to have a sine with the same value. So first of all, I'm going to seek theta by finding the arcsine of negative 0.4313. Okay, so if I calculate that, the arcsine of negative 0.4313 is negative 25.55. Remember, that's actually not theta, that's phi. It's a negative angle that's in the opposite direction. So if I want to find the actual angle theta, I can add 360 to that. So if I add 360 to that, I get my measurement for theta, which is 334.45 degrees. Now, to check it, if I take the sine of 334.45 degrees, I should get negative 0.4313. It's 0.29 right there instead of 3 because we made some rounding as we got that angle. All right, so that's how I can get an angle that is not just the reference angle. Okay. Now, in this particular case, these two are coterminal, so it's actually okay to have used either one of those because they are coterminal. However, in part A, that is not true. The 13-degree angle is not coterminal with the original. I absolutely had to find the other angle. It could have been measured in a negative measure, but it would not have been negative 13. It would have been some other value. In quadrant 4, this one happens to come out with a negative measure of the same angle where these two are coterminal. That does not always happen.